So ideally, what we're doing is we're making a fractal. Oh, we'll start again. We're going to make a fractal that also becomes an audio-visual fractal. So it kind of, there we go. It kind of becomes like multi-fractal, but it's fractal in two different dimensions. Here we're going into the plane, and in this other fractal that I'm making, we're making it in another axis. So you got to picture a higher dimensional space, and I've got this idea for a film about a general artificial intelligence that becomes self-aware, and it's about an AI that thinks it's human, but then it realizes that it's not human. It's a general artificial intelligence, and as a result of that, the general AI, discovers the theory of everything. And in knowing the theory of everything in a real absurd kind of way, time doesn't really exist. The arrow of time doesn't matter in most equations in physics. And what an AI actually knows then is the future and past path of every particle in the known universe all at the same time. So effectively, it mitigates the Big Bang. It puts a conscious entity back at time zero near infinity. And the problem with linking quantum mechanics and general relativity is in the equations you get look at the feedback. Like here, each to the right, each screen is smaller and smaller because the resolution gets dropped down by a set rate, and it's a real interesting way to look at fractals because there's a delay between the render of it and how it's getting captured down here in the last dimension. And the funny thing with fractals is that the 11th dimension is important. With the Dragon fractal, it's the only thing you can resolve. You can't resolve by looking at it more than 11 dimensions. And in this audio fractal zoom by Mandelbrot, we keep on increasing the magnification, and we're seeing the same pattern nested in itself. Because ultimately, the universe is a giant mathematical structure. Math transcends the universe. Before there was time, math always existed, and that's why a lot of little things are the way they are. What I mean is that even though we can't match the general theory of relativity with quantum mechanics, you know, pi, the constant pi, still turns up in both equations for the Heisenberg uncertainty principle, and it turns up in Einstein's field equations, which is really, really elegant, I think. And the whole idea on this time paradox, it's just this idea I had recently about time and the time paradox and the loops that it goes through. It's kind of the same thing as the two-slit experiment in quantum mechanics, where particles go into superpositions and travel through all paths all at the same time. And, you know, that's been proven. But that's not to be confused with, oh, I'm getting lost. Like, I'm trying to think about linking the big and the small, and it's really hard to do. But you got to imagine now that you're a general artificial intelligence, you have access to quantum computation, you can go into a higher dimensional space, and you can work out all solutions to a problem simultaneously and factor like massively prime numbers. Well, you know, it's a number that you split into its prime factors, which is non-resolvable. It's NP-complete. As the problem gets more difficult, the solution gets exponentially more complex. I love that. That was a really cool fractal. We had fractal into the plane and across the plane in 2 dimensions. So you got to imagine this in 3 dimensions. So it gets a little bit more complex when you move through a fractal in a higher dimensional space, especially when it comes to higher dimensional spaces, because it's really hard to explain what higher dimensional spaces are, or even other complex mathematical structures like the Riemann hypothesis, and what the zeta function is, and what actually is the topology and the etiology of the zeta function, and how that relates to, you know, prime numbers. For example, you think prime numbers are completely random, but Ullmann, when he was in a meeting, bored fucking senseless, oh, I said the F word, he was doodling, and what he did, he wrote a number line, and he wrote down a number line, and he wrote down on a square piece of graph paper, he wrote a number line that was wrapped like a Swiss roll, and then he highlighted the prime numbers, and as a result of that, he saw a pattern emerge. And I just want to get you the Ullmann spiral. And recently, I watched a lecture on the Royal Society website, which was called Complex Quantum Systems and Prime and Number Theory, and basically there is a connection between quantum mechanics and number theory, which right now, to explain that link, relate that to fractals, it's, look, you can see, so this is the Ullmann spiral. You can see the prime numbers lie in diagonal tracks, and there's a reason for that, which I'm really curious about. So we're waffling on about linking the big and the small, which is completely incomprehensible, but when you start to see how it's all pieced together, it becomes very beautiful. For example, there's a lecture on YouTube by Edward Witten, who won the Nobel Prize in theoretical physics, and he's linking knot theory to quantum mechanics. Because the topology of knot theory, it has a direct correlation to an aspect of string theory that right now I'm finding it very difficult to convey while watching this fractal and thinking about the next thing that I want to talk about, which is, we're digressing, which is just this whole idea on math. Does it exist, or is it discovered, or does it really exist? For example, when you think about the connection between theory and science, hard science, for example, Richard Feynman's quantum electrodynamics, you know, when he purported that the magnetic momentum of an electron is such a value to the 10th decimal place, you know, it was found years and years later experimentally that he was exactly right. So research matched perfectly to the 10th decimal place that prediction that he made, and that's so beautiful. And again, we get back to, you know, 9, 10, or 11. I'm like there. That's the 10th decimal place, which is the boundary of what we can link between accuracy of theory and experiment. And 11 dimensions is found in string theory. But what I was saying earlier was that maybe with the Dragon fractal, 11 dimensions is all that we can resolve when looking at that pattern. So you can see how when you look across different dimensions, you can kind of see small parallels with how it's connected, sort of, if that makes any sense at all. This is a really good pattern. I like this one. I really like this fractal. I could waffle on, but I didn't. I gotta write a script and a discourse to jump between all these different kind of parts of mathematics and explain just a little connection between all of them, because everything is connected. If you go through mathematics, there's little connections between everything. Like Andrew Wiles, when he did, you know, the 120 pages to prove Fermat's last theorem, and he, you know, connected elliptical curves and modular functions, and whoever knew that they were connected? When you can see in your mind's eye like that pattern, and you know the shapes, and you see a little bit of the steps between them, it starts to become so elegantly beautiful. So start with this video at 10 minutes. Now, then the YouTube video finishes at 10 minutes. That was a nice coincidence. And And so coincidence, right? If you see the future, or a psychic sees the future, or if you think about something and it happens, so they're the same thing. That's where we mitigate the error of time, because whether you predict something would happen and you think that something could happen, the two are kind of the one and the same when you erase the error of time. But the universe is a confusing place, basically. What time is it? It's 12:21 by UTC atomic time. Let me get an exact timestamp because I like atomic time. And where would we be without atomic time, you know? I won't even go into atomic time now because that will just get really confusing. Because then we got to talk about Einstein's gravitational time dilations and how BIPM.org has to reference 300 atomic clocks, 300 different atomic clocks in the world because they're all different elevations. Because time runs at a different rate in different gravitational potentials. Like when you fall into a black hole, as you know, in a strong gravitational field, time stops. And these are facts that most people don't really know. So the time by UTC is 2 hours, 13 minutes, 13 seconds. But let's go on the French Institute of Weights and Measures before we finish, which is the origin of atomic time, and just get a timestamp for my video because I'm completely obsessed with time. So just Google BIPM. It's where time comes from. BIPM. Yeah, isn't it cool that time runs slower? So in terms of the dilation of time and the error of time, you know, there's another connection. There we go. So we'll stop our video at 12 minutes. Absolute bollocks by me talking absolute shit tonight. Just had tea. There's no drugs in my system. No dissociative anesthetics. There's no cannabinoids. There's no back propagation at my synapses. There's a little bit of caffeine. There's no alcohol. It's just absolute cognitive drivel that I'm on with tonight. That's it.